This session we're going to look at a 19, let's see, it's either 1901 or 1910. The earliest date in the patent list is 1890, and the latest one is 1903. So this is a kind of meter that was available back when Tesla was doing his experiments and stuff. So what it is it's a voltmeter and amp meter. And we're going to go ahead and hook it up and we're going to see what it does. Now, it has a set of connections here. Instead of a switch, they use this connector that is tapered, and when you shove it down on there and push it, it fits very tightly. So you could select the range just by moving this to the various positions. Now, the range, we've got one which is 125 volts. We have one that's 5 volts. And we have one that's it's 25 millivolts. Okay. We'll just have to go ahead and take that for a grain of salt. Because when you're looking at that low of a current, the impedance of the meter is drastically serious. You have to take the impedance of the meter into effect when you're making the measurement. Okay, and then here we have a amps. The lettering on the amps has pulverized off. So what we'll have to do is we'll connect a power supply onto it, and we'll go ahead and see what full-scale amps are on there. Okay. Well, why not start with the amps? Let me get some clip leads onto the power supply. They don't really say. Okay, minus is going to be this one here, okay? Down here they have a little dealie that says minus on it. Okay, and then the plus will be this one here. Okay, what I'm going to do is I'm going to hook another meter in series with it so that we can have a reference. I got the 630 over here, and I'll set it on the 1 amp scale. And we'll connect the power supply to it. And we'll connect the other one onto the input. And we'll see what the thing does. Now, I'm going to set it to 1 amp. Up. Okay, I can't do it. It's too low of an impedance. So the slightest change in the voltage causes it to go full scale. All right, let me get a power resistor. All right, this one here is 10 ohms. And we'll go ahead and connect it in series. Clip lead. It is a bear to squeeze those things. Okay, now that's 10 ohms in series with. Let's see what happens now. Oh, there we go. Okay. Okay, I got the triplet set to 1 amp. It's reading 7 on the scale. Wow, that's a really nicely thought out shunt on there. If they had any common sense, they would have had that to where 1 amp would have been on 10, and that would be a nice even scale. Okay, now we're reading 7. Let me put it to the opposite polarity and see what it reads there. See if the meter is satisfactory in both polarities. Let's see here. Okay, it's reading 6 in this direction. So you can connect it up one way or the other and take the one that you like the best, because sensitivity is not the same each. Okay, now full scale. Let's see what. Give me on to 10. Okay, there we go. Okay, that's right at full scale, and we're reading on a 10 amp scale. I'm reading 4 amps. Okay, and we're reading 25 on there. Okay, and likewise, now this should be a little past full scale. No, a little less. Okay, that's 24. All right, so full scale on the amps is 4 amps. It's not linear. Yeah, okay, because it's 7, and then it would be 4 times that would be 2.8. So there's a little bit of screw up there. Okay. All right, let's see what it does on voltage. This is one of those chink clip leads. The damn thing's so hot with only 4 amps going through it. It's so hot I can hardly hold it. The wire inside of here, I had one of them that I changed the connector out. I changed the clip out, and I mean that wire is so thin that it's good for signals, and that's it. You can't use it for any kind of power. Like the wire on my ohmmeter. Now this is number 16. It's test lead, professional test lead wire, and it's a very stranded wire, and that gives it a nice low resistance through the circuit. Okay, now for measuring the voltage, okay, let's take it. I'm going to move our selector over to the milliamps. Okay, that's the 25 milliamp one. All right, there we have our triplet hooked up in there. Now I'm going to put it on a 100 milliamp scale, and okay, turn the power on. All right, got the current turned to nothing. Okay. All right, so it's right at full scale, and we're reading, it looks like 22. Let me get the digital unit going here. Okay. Okay, we're right at full scale, and we're reading 23.7 instead of 25, which is, that's probably okay for the day that this was made. Okay, now here, same thing. Now this one reads virtually the same in both directions. So for some reason the amps, I guess it's because the voltage is lower. Here we're measuring quite a bit of Let me get over on the voltage here. See what we're reading. No, it's millivolts. We're reading millivolts there. Okay, so that is correct. That's with our selector. Our selector jumper is on the milliamps one. Okay, let me connect it to the 5 volts one. Okay. Okay. All right. That's minus in here. All right. It's 5 volts, full scale. Okay, I'm going to run that up. That's full scale. We're reading 4.84 volts, full scale, okay? And if we switch polarity, okay, it reads the same. Okay. The next one is 125 volts. Okay. All right, now that's no use anymore. Okay, I need power supply with more voltage. Okay, onto the high voltage supply here. It's not really high. Goes to 500 volts, which is, yeah, not really high, but it's there. Okay. Okay, now. Okay. That's a hell of a power supply. Okay, it's supposed to be 125 volts. I'm reading 112 volts. And here we're reading about 23. Okay. And if we switch the, okay, now don't touch stuff. Okay, it's reading the same both directions, so that's good. So 125 volts. Now wiggling this. Okay, watch out now. Okay, so the connections are good. So 5 volts is 25. You have to multiply whatever you get here by 25. So basically we take each one of these and we multiply it times 5. Why didn't they just print that on the damn meter? Who knows? Well, that's 1903 meter. I would say they probably had a specific use for this meter. And they didn't really care what the scale was. It was such that when they had it hooked up at a certain circuit, this is telegraph equipment, then if they got a 10 reading on here, they'd say, okay, that's correct. They didn't plan on using it for troubleshooting and stuff. They were just probably going to use it just for matching a value to what it is known to be desired. So they didn't really care about it. They just put any old scale on there. You know, they may as well have made it 1 to 10. It would have been a little bit a little bit easier to comprehend. But okay, that was an interesting old meter. I picked it up for $100 even. I paid for it. Paid $100 even for it. There's one on eBay right now for 150, something like that. It's in a lot lousier condition than this one. Okay, that's it.